Okay, today we are talking about ribs. So, what is a rib? Well, rib stands for relay in a box.
Wow.
Here's an example of a rib. They come in different configurations, but here's sort of a ubiquitous rib that you'll find in the HVAC space. And you can see this one has a little red LED that lights up when it's powered on. It comes with multiple wires, as you see, and each wire serves a specific function or purpose. This one also comes with a 1/2-inch threaded fitting on the bottom, so it makes it quick and easy to install inside of an enclosure, a J-box, etc.
Woo!
When you're ordering a rib or replacing a rib, you want to pay special attention to the data sticker on the rib so you order the correct one, because there is not a one-size-fits-all. So let's take a closer look at the data sticker. So this one, by Functional Devices Incorporated, is a RIB-U1C. And you can see we have our coil ratings here and our contact ratings here. So what does that mean? Well, inside this relay in a box, you have a coil, and when the coil is energized, it's going to close the switch or the contacts inside the rib. So you can see in this wiring diagram, your blue wire and your yellow common wire are normally closed, and your orange wire is normally open. So what does that mean? That means in its resting state, when you don't energize the rib, you're going to have constant power coming in on your yellow common wire and going out on your blue normally closed wire. When you energize this rib via the relay, those switches it'll change state. So when it's energized, you have power coming in on your yellow common, but now it's going to go out on the orange normally open wire. So yellow and orange will be closed, providing power to whatever the equipment is. And then the blue, normally closed, will now be open.
Wow.
On the coil side, you can see that you have white and black wire. The white and black wire is 120 volt AC. And then the white and yellow wire would be your common or neutral wire. Conversely, if you're working with 10 to 30 volts AC or DC, you would land that wire on the white and blue wire and then still connect your white and yellow common or neutral wire. And then you would simply wire nut off or cap off the white and black wire, or vice versa. Again, if you're using a 120 volt control, you would cap off the white and blue wire because you're not using that. So I hope that makes sense. And usually what energizes the rib or energizes the coil inside the rib would be like a controller on the side of a fan coil unit, a BAS system, or maybe a 24 volt signal from some sort of control. So let's look at an example. So this is a 480 volt electric duct heater on a fan coil unit. So what is this diagram showing us? Well, on the left-hand side, you have 24 volts or 120 volts AC coming in. That's the yellow wire. That's your hot wire. Again, providing constant power to the yellow wire on your ribs. We have two ribs in this diagram to control this 480 volt electric duct heater. And then you see we have a wire connected to the orange, normally open terminal, the orange normally open wires on each of these ribs. So rib 1 controls the top contactor. Rib 2 controls this bottom contactor. So when your controller energizes the coil inside the ribs, you're going to then send power to the coil on the side of your contactors. The contactors will close and you'll energize your electric duct heater. You can see in this wiring diagram, the neutral for the 24 volts or 120 volts comes in through an auto limit switch, then through an air pressure switch to each side of the coil on your contactors. Those are safety devices because, again, this is an electric duct heater and we do not want that electric duct heater to turn on if the blower fan is not running. So we first need to see that air pressure switch close. That means that blower fan is running and it's safe for the duct heater to turn on. So I hope that clarifies what a rib is and how they're used in the real world. Please like, share, subscribe, leave me a comment, and thanks for watching.